Hi. In this video, we are going to study a very important model useful in building solutions for reinforcement learning. See, we have to first look at reinforcement learning. In reinforcement learning, what happens is there is an agent which is continuously doing actions. For every action, there is a reward. So we expect the agent to learn. Of course, there are some possible actions for performing, from which it selects one action and performs. Some reward is given. Next time, it chooses another action. So, over a period of time, depending upon how much reward the agent gets, so now the agent learns how to behave. So, that is about reinforcement learning. In statistics, there is a decision model called finite Markov decision process. Finite Markov decision process is about a scientific approach for selecting an action, that is taking a decision. This is a decision process. So what decision? How to take a decision based upon the historical data. So finite Markov decision process is useful for the reinforcement learning. That is why we build certain examples and structure them as a finite Markov decision process. Let us see what is that. For example, supposing there is a state called E, there is a state called A. This is a very simple model in which you are in state A or you are in state E. If you are in state A, there are two possible actions you can do. The first arrow in the right side is one possible action, and there is a downward arrow which is another possible action. If you do the first action, if you select the first action and perform, you will get some reward. Whereas if you deliver the second action, then you will get another reward. But the policy, the agent selects the first action with the probability 0.6. It means 60% of the time it chooses action 1 and 40% of the time it chooses the action 2. In a similar manner, if you are in action E, then there are two possibilities. One is you take another action which leads into E itself, the final state is E. Whereas another probability 0.7, if you choose this action, you will go back to A. So, in finite Markov decision process, there are states. For each state, there are some actions. For when you perform each action, you get a reward and you land up in another state. So these are the three things. What are the three things? One is you are having some finite states. For each state, there are some finite set of actions possible. Whenever you perform one action, from that state, you reach another state and you get a reward. For each of the possible actions, there is a probability attached. What is the probability? that you are doing. So this is the broad background about the finite Markov decision process. So Markov decision process are classical formalization of decision making. Actions influences rewards, not necessarily immediate but also subsequent situations. So you look at the picture, there is an environment, the agent is at a particular state. For example, look at it, state SI. You are in a state SI. And when you are in a state SI, the agent has to choose some actions. The agent chooses action AI. When you do action AI, it impacts the environment and you are getting another state. So when you perform action AI, you enter into another state called SI plus 1 together with a reward RI plus 1. So this is the way it is continuing. For example, so there are three things we are talking about: action, reward, state. So at each time t will be 1, 2, 3, 4, continuously it will be changing. The agent receives a representation of state ST. So the agent is at a state ST at a given time t. Now there are certain possible actions that is called A. A is action space. From the action space, now the agent chooses an action called AT. Now, when AT is chosen and performed, two things happen. One is the state changes from SI to ST to ST plus 1 and you get a reward of RT plus 1. Then you continue. So the agent finds itself in state ST plus 1. So what are the consequences? The continuously S0, you are at the initial state SC0, then A0, choose A0 and you get a reward of R1 and you reach S1. You choose action A1, you get a reward of R2, you reach S2, A2 and so on. So the agent has to learn. So reinforcement learning is all about the agent learning to choose the actions so that the maximum, you maximize the cumulative reward in the long run. Over a period of time, cumulative reward must be high. So that is the background. Now, there is also a probability attached. For every state, when you are at a particular state, yes, if you choose an action, you will reach another state, S dash. And probability that you reach S dash with R, reward R, from S and A. So you are given S comma A. It means you are currently in S state and you are choosing action A. So then you will reach a final state S dash with reward R. So that probability is denoted by P of S dash comma R given S comma A. So it is the probability that the current state the current state is the current state is S, that is ST minus 1, and there you get a reward of R. So this function P defines the dynamics of the Markovian decision process. Examples. There are some examples we can see. For example, you consider a bioreactor. You apply certain bio content inside the bioreactor and you can take some actions. What are the actions? You can stir the content or you can change the temperature. So these are all the actions. So when you are in a particular state, the state is defined by the sensor readings of various things, the temperature, pressure, and so on. So that defines the state. Now, your actions are, you can either stir or you can increase the temperature and so on. So they are the actions. So the reward is the rate of output of the useful chemicals. So what is the reward? So now, based upon these things, over a period of time, every time you stir, this is the reward that you are getting. Every time you change the temperature, you get this. So from each state, you are getting. So the objective is that the bioreactor has to learn, if you are in a particular state, which action should be done, how you want to stir, how you want to change the temperature, and so on. That is the example of a bioreactor. In a similar manner, there is also another example called pick and place robo. For example, there is a robo which is capable of moving, and it will pick up something. For example, it can pick up some waste from the room and drop it in the dustbin. So that is pick and place robo. So the pick and place robo is controlled by several motors in the arm. So it has to move, it has to turn, it has to pick up, and then it will have to drop. So the state is defined by the current position, latest readings of the joints, angles, and velocity. So that defines the state of the system. So action is, there are several motors attached to the robo. So actions are where a higher voltage must be applied to which motor. So if you apply, the motor will start working and the arm will start moving. So the action has to be decided. Here the reward is, if you pick up and drop, and then you will get a reward of +1. So now the robo has to learn how to pick up, how over a period of time, what sort of voltage must be applied to various motors under which circumstances. So this is a reinforcement learning which uses the Markov decision process. Let us look at another example. This is a classical example normally we use to help people understand reinforcement learning. See, simply there is a 5x5 grid. In the 5x5 grid, each cell is called a state. For example, what is the top left one, the northwest corner, the top left one is called the northwest corner, which is 1, 1. Then the right side, 1, 2, 1, 3, 1, 4, 1, 5. So this is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. In a similar manner, it goes up to 5. So this is the state space. So this is called the state space. The space consisting of all possible states. Now, if the agent is in a particular state, what are the possible actions? Either it can move up, which is northwards, or it can move down, which is southwards. You can move right, which is eastwards. It can move left, which is westwards. So the possible actions are up, down, left, right, or north, south, east, west. These are the actions. The agent can choose the action. Now, one important disclaimer is, if the movement would take off the grid, then the location is unchanged. For example, you are in 3-1 and you move further left, no, you will bump on the wall and fall into the same cell. Whereas if you move right, 3-1, if you move right, you will go to 3-2. Similarly, you are in 5-3. If you move down, that is south, then you will bump on the wall and fall back into the same one. For example, 1-1 east, if you choose east, you will go to 1-2. Whereas from 1-1, if you move north, you will be in 1-1. From 4-1, 4-1. If you move west, west means left side, then you will continue to be in 4-1. So these are some important things. So what have we studied? We have studied what is Markovian decision process. So Markovian decision process talks about states. For each state, what are all the possible actions? For each possible action, it will take you from one state to another together with a reward. And for each possible state, if there are some finite number of possible actions, the probability is also given. So the objective of reinforcement learning is to find out a policy in such a way that the total earnings are more. We have seen 3 interesting examples. One is a bioreactor in which stirring, you stir or you change the temperature and do something. There, the reinforcement learning agent learns how much it should stir, how much the temperature, so it chooses the actions. Similarly, we have also seen another example. The second example that we studied was about pick and drop robo, because the robo has several motors in the robotic arms. So depending upon a particular state, it has to learn whether to move left, right, or pick up, or what is to be, what are the possible actions to be taken. The third example is about the 5x5 grid in which there are 5 into 5, 25 states. For each state, there are 4 possible actions: up, down, left, or right. Now, each one will be attached with a reward and a probability. So the policy will be defined, and accordingly we can compute the total reward. Thank you very much.